All right, guys. So this is going to be the answer key for practice 4.2. So again, the best way to use this is to finish practice 4.2 on your own and then check the answers. But if you're totally lost, you can always just watch the answer key from the beginning. So um, what I want to do for this is the same thing I did the other day. So I'm going to go back to my notes. And so you guys all have this set of notes, right? It's the part where you had, you just took these notes. And I'm going to cut out this equation. There we go. Copy. And so the two equations that I have for objects that are thrown in the air are going to be that one. I'm going to make that a little bit smaller. Okay, so there's my first equation. And here's my second equation. Copy that. And so you could obviously copy these from your own notes. You'd have to use your own hands though instead of your fancy tools. All right, so those are my two equations. Those are the only two I'm going to use for this one. All right, so A, Mr. McSparron throws a ball straight up with a velocity of 20 meters per second. How long does it take the baseball to reach its highest point? Okay, so if we think about our process, so the first thing you want to do is identify what it gave us. So the given here is 20 meters per second. So I'm going to write 20. And I need to figure out what is that it gave me. So meters per second tips me off that it's a velocity. But I've got VI and I've got VF. So I need to figure out, is this VI or is it VF? Well, when it tells me the velocity when I throw it, that means the velocity at the beginning. So this is actually my VI. Okay? So my VI is 20. And I'm just going to fix up that 0 because it kind of looked like a 6. It's a 0. There we go. So my VI is 20. And let's see what they ask for. So they ask me for how long will it take. Well, how long will it take usually means a time. And so that means that my delta t is going to be the question mark. Okay? All right, so it's asking me how long it's going to take. So obviously, if I look up at these two equations, these two things here, it seems pretty clear to me that if I have VI and I'm looking for delta t, I got to use this one right here because the other one doesn't even have VI or VF in it. So let's use that one. Let's zoom in. VF equals VI minus 9.8 delta t. Okay, so I've already got VI. I've already got delta t, that's my question mark, but this also has VF in it. So I need to put VF over here, VF. And so I'm going to need to figure that out. So if we think about this, VF, if we go back to the lab, we said that the velocity at the highest point is 0. And this says highest point. So that means my final velocity, because I'm talking about how long it takes to get from the bottom to the top, my final velocity is 0. So I'm asking, how long does it take the ball to slow down from 20 down to 0? Okay, so I'm going to plug stuff in. So VF is 0, VI is 20, and I'm trying to figure out delta t. Okay, so to get delta t by itself, first I'm going to subtract 20 from both sides. So I'm going to get negative 20 equals negative 9.8 delta t. I'm going to divide both sides by 9.8 now, negative 9.8. And I'm going to get delta t equals, now on my calculator I'm going to do 20 divided by 9.8. 2, God dang it, it's doing it again. 20 divided by 9.8, and we get 2.04. So my answer then is 2.04 seconds. All right, so that's the answer to that one. All right, now, how high will the baseball go? Now, assuming that the point where the ball leaves Mr. McSparron's hand is y equals 0, that means they'll measure the maximum height from Mr. McSparron's hand, not from the ground. Here's all I mean, okay? So if here is Mr. McSparron, okay? I know my stick figures stink. You guys have been telling me that. You don't need to tell me. I know. All right? And if I throw a baseball up and then down, what I'm asking for is the distance from my hand to the highest point. I'm not asking for the distance down to the ground, okay? That's not what I want, so I don't care about the distance down to the ground. Uh-oh, come back. There we go. So I'm asking for the distance from my hand to the highest point. So now we're going to use this y max equation. So y max equals 4.9 delta t squared. Y max equals 4.9 times delta t squared. So my two variables here are going to be y max, which I don't know. That's what I'm trying to figure out. Ooh, I almost drew a 2. And then delta t, which my delta t is going to come from right here. So my delta t is 2.04. All right, so I'm going to plug in y max equals 4.9 times 2.04 squared. So now I'm just going to simplify. I got to do 2.04 squared and then multiply it by 4.9. So let's do that. So let's clear. And then 2.04 times 2.04 equals 4.16. And now I have to multiply that times 4.9. So I go times 4.9, and I get 20.39. Okay, so I have y max equals 20.39, and that's got to be meters because it's the height. It's the maximum height. Cool. All right, there's the answer to the first two. Number 2, when Michael Jordan jumps, he can reach his highest point in about 5 seconds. Excuse me, 0.5 seconds. What's his initial velocity when he leaves the ground? So, what are they giving me? They're giving me a number in seconds. That's got to be delta t. Delta t equals 0.5. And then they're asking for initial velocity. So vi is my question mark, which means I'm going to use this equation again. Vf equals Vi minus 9.8 delta t. Now I'm going to plug in. I need a value for Vf first. So here Vf is equal to 0, because again, highest point means Vf is 0. And this is asking for highest point. Highest point means Vf is 0. All right, so 0 goes there. Delta t is 0.5, so Vi stays there, minus 9.8 times 0.5. So I'm going to do 9.8 times 0.5. So I go clear, 9.8 times 0.5. 4.9, that's not surprising. We've seen 4.9 a couple times before. 0 equals Vi minus 4.9. I'm going to add 4.9 to both sides now. All right. I'm sorry I ran out of space. I'm going to end up with Vi equals 4.9, and it's a velocity, so it's got to be meters per second. Now, how high can MJ jump? Well, now I'm just using my Y max equation again. So Y max equals 4.9 times delta t squared. And over here, so I've got Y max is my question mark, and delta t, it told us up here before, is 0.5. Delta t is 0.5. So now what I'm going to do, y max equals 4.9 times 0.5 squared. So I'm going to go and I'm going to do 0.5 times 0.5. Clear? So that's 0.5 times 0.5, 0.25 times 4.9 equals y max. So my final y max is going to be equal to 4.9 times 0.25 times 4.9, 1.225, so we'll call it 1.23. Y max is 1.23 meters. All right, cool. By the way, that's a pretty big time vertical. That's like 48 inches. That's really, really high. It's like 4 feet. MJ can jump. All right, now how long can he stay in the air? So now what we're talking about is MJ, all right, and MJ has to be like that. That's how MJ jumps, right? So how long can he stay in the air? So when he goes up and back down, what's the total time up plus the total time down? So now all we're looking at is we know that it takes him 0.5 seconds to go up. Well, we also know that it's going to take him exactly the same time to come back down, right? That's what we said, right? Yep, 0.5 seconds. 0.5 seconds. So he's going to stay in the air for a total of 1 second. Oh, why did I do that? Let's just do 1s. So it takes 0.5 going up, another 0.5 going down, the exact same time coming down, and he's going to end up with 1 second in the air. All right, there we go, guys.